Hey guys, it's Alex from Sidewalk Science Center up at the Brainton Riverwalk, and today is a kind of a special video because it is very early out right now. It is about 3:20 in the morning on Sunday, May 3rd. So you'll be watching this tomorrow. Right now it is Sunday morning, and behind me, right here, we have the moon, and that's actually what the telescope is pointing at. But there are also two very special objects in the sky that are rising at about 2:30 in the morning right now. And over the next couple months, May to June, they will be rising earlier and earlier to the point in July where you can walk out as you're going to bed, take a look in the sky, and you'll see these two objects. And those two are right there. That bright dot that you can see right there is Jupiter, and this really tough one to see next to it is Saturn. So we have Jupiter and Saturn up in the sky, and that's what we're going to take a look at tonight using the telescope that's right there. So let's come over to the telescope first of all, because right now we do have the moon is past its first quarter phase. It is heading towards its full phase, and its full phase will be coming on Thursday. So Thursday, May 7th is the first full moon, or is the only full moon of May. So put the camera right down on it. Had a glimpse of it there. Looks like I'm gonna have to actually tilt it a bit. Slid a bit out of frame. There we go. So you might notice that it kind of looks like it's underwater a little bit, and this is because as the moon is setting, it's becoming closer and closer to the Earth's horizon. And what you are seeing is some of the moisture in the air. You're seeing some of the heat in the air. It's shaking the air molecules, and thus the light coming through those air molecules is also waving. And this is just known as aberration or atmospheric turbulence. It's very similar to on a hot day like you see on the road or you see above cars or grills, how the light kind of distorts above hot stuff. It's essentially the exact same thing, except it takes place with objects way out in outer space. And with the moon, it's not too bad, but when you're trying to look at Jupiter and Saturn and other small objects in the sky, that aberration, that turbulence can really disturb the image. So it's best to look at objects in the sky when they're high up, when the moon is high up in the sky and not down low to the horizon, or when Jupiter and Saturn are way up in the sky and not down low to the horizon, because then they just start to shake around, and it's very difficult to get a clear picture of them. So while we're at this, because this is going to take some time, press some buttons here, and let's go to Jupiter first. So telescope, it's moving all by itself right now. It's turning, it actually has to do a nearly 180-degree turn, because the moon is on that side and Jupiter and Saturn are on that side. But let's talk about where they are right now. So the moon is setting in the west. The moon is setting in the west right there. That's about west, a little bit northwest. And up here, if this focuses, I'm not sure if it will, but up there, actually slightly coming into frame focus, is the Big Dipper. So I am standing pointing nearly directly north right now. So the North Star is somewhere in this area. And then, so there's the moon again. And then that means that back here is directly south. If this light wasn't an issue, if I could actually move sideways, that star, that bright star you're seeing right there, that is actually the star called Antares. And Antares has one of the nicknames of the Heart of Scorpius. And Scorpius is a summer constellation, and directly beside Scorpius, off to the left out of the frame, right behind his light actually, is the constellation of Sagittarius. And directly between Sagittarius and Scorpius is the core of the Milky Way galaxy. So the very center of the galaxy that we live in is directly between those two constellations. It's right about there. So it's getting very fuzzy, but we'll fix this up soon. So Scorpius kind of runs from right here, runs down, and kind of hooks back around. It has a scorpion's tail. And when you see it without a massive light sitting right next to you, you see Antares is really bright, but then there's like the hook where the claws are up at the top, and then where the kind of upside down question mark is at the bottom is the tail of the scorpion. And we're not going to get into this tonight. If you come to Sidewalk Science Center and use the telescope, which is now pointed the correct direction, and use the telescope, you can actually see star clusters and nebula through this telescope around Scorpius and Sagittarius. And as you look through a telescope, because the Milky Way is right there, you can see all sorts of stars and gas clouds as you're looking through the telescope. But now we have this pointing at that bright dot. And actually you can see Saturn coming in a lot better if I slightly move this out. So Saturn is that tiny dot down and to the left of Jupiter. And to put this in perspective, Jupiter and Saturn were very, very, very far apart last year. You would have to swing the telescope from one side to the other in order to see them. But because Jupiter orbits about twice as close as Saturn does, it has caught up, moving counterclockwise in its orbit. It's caught up to Saturn. And actually this December, it will pass Saturn. So pay attention to these two lights up in the sky. Actually, if you make a peace sign, one is on each finger. Pay attention to those two lights up in the sky as the year progresses, because Jupiter will start to get very, very close and then become underneath and then pass Saturn in December. So obviously I will be talking about that if you see Sidewalk Science Center, or I will be making posts about that. But let's get to the point of this. I have this hopefully on Jupiter. I'm going to check this real quick. Make sure it's in there. And we do. It's barely off to the side. So I will center this. And let's take a look. All right. So when you see Jupiter, Jupiter has 4 Galilean moons. And they're called the Galilean moons because Galileo Galilei, who was the first person that we know of on record to point a telescope up at the sky. And when he looked at Jupiter, he saw 4 bright dots moving around it. And those 4 bright dots, which we can actually see with fairly powerful binoculars and definitely telescopes, are moons of Jupiter. 4 of the something like 68 or 72 moons or something that Jupiter has. It's a very large number. But these 4 are visible as bright specks of light next to Jupiter. And right there you just saw a glimpse of them. So it's hard to tell in this view, but those two, that dot on the right hand side is actually 2 dots. So I know it's a bit hard because the overexposure of a phone camera tends to do that. But you saw 1 dot over here, and then you saw Jupiter right in the middle, and then you saw a big dot over here, but that big dot was actually 2. Those were 2 moons. And standing out here, it's 3:15, it's 3:30 in the morning at this point. I'm not going to stand out here for 3 hours and watch Jupiter, but I have done that before when it's 8 o'clock to like midnight, and you can actually watch the moons move around Jupiter. Because the closest two, Io and Europa, travel so quickly around Jupiter, about 44 hours and somewhere in like the 50 or 60 hours, that you can sit here for 3 to 4 hours and watch them travel. You can actually watch Io, Ganymede, Europa, and not so much with Callisto, the 4th one, the farthest one away of the 4. But you can actually watch them pass behind or in front of Jupiter. And if you have a powerful enough telescope and a clear enough night, you can see an eclipse, a black shadow from a moon, pass across Jupiter. It's so cool to see with your own eyes. It is something that we have seen at Sidewalk Science Center. These are regular events. They happen nearly like every time a moon goes around Jupiter, because those moons are so close. They pretty much always cast a shadow on the face of it. So they are very regular. You just have to catch them during a nighttime, because for something like this, it's very difficult to see it during the daytime, which is possible, just not, easy to do. But now, I'll still talk about Jupiter as we're moving. I will set this onto Saturn next. But one more thing about Jupiter is it has the famous Great Red Spot. And I can post this picture. I took this picture last year, but I actually have a picture of Jupiter without the moons because I had to lower the exposure so the moons just vanished. And you can see the great red spot. You can see stripes across Jupiter and the great red spot. When you see it with your naked eye, you know, a lot of times you see like this pinkish circle when you see like Hubble pictures or NASA pictures. But with the naked eye, that great red spot truly is a great red spot. It looks like a drop of blood on the face of Jupiter. It is so incredibly red that when it's on the face, there's no mistaking it. It's very, very cool. But now we are moving to Saturn. Trying to keep this in a reasonable time frame for everybody. So let's make sure that this is almost dead center on there. Cool, cool. Now, again, this is going to be overexposed. I highly recommend that you come out to Sidewalk Science Center, use this telescope. Remember, June 19th is the next time that this telescope is going to be on the Bradenton Riverwalk at the splash pad and playground. That is June 19th. When you see Saturn through the phone, it's going to look like a bright oval. When you see it with the naked eye, with this telescope, it is incredible. I have let thousands of people use this telescope already to see Jupiter and Saturn, and when someone sees Saturn, you know, it can be anything from this like hushed gasp to just a shout of joy or something. Like, people get so excited when they see Saturn. So I'm sorry that it's going to be overexposed when you see it here, but I'll do my best to like at least show what I can. So you can tell that it's definitely got rings because you can see it's that oblong oval shape. I'm going to zoom in, see if we can separate something. Darken this. There's a little bit, you can kind of see the rings. You can see a little bit of the gap there. And of course, Saturn is being overexposed right now. I'm going to switch this back. Saturn is being overexposed right now, so it looks very bright white in the phone. But in reality, Saturn has this yellowish tint to it, this yellow-brown tint to it when you see it with the naked eye, like, or, you know, aided with a telescope. You can see some moons around it, but it's the rings that make it so beautiful because, you know, you look at Jupiter, yeah, you can see the moons. You look at the moon, you can see the craters. Every planet, every body up there has its defining feature. And when you see Saturn's rings, when you see that halo around the orb of the planet and the two black spaces in between where the rings and the planet are, it's just so, so cool. Those rings are so reflective because they are made of mostly water ice. You could dunk this ice in your drink, cool it down, and, you know, that's what they're made of. They're made of cometary debris. So comets are chunks of ice and dirt and salt and other elements and materials. And as they get close to bodies with strong gravitation, or even the sun as it's heating them up, they release their long tails or they break apart. And around Saturn and even Jupiter a little bit, but Saturn is the one that you can see. It's theorized that it's comets that were breaking apart, entered around Saturn, and now that's what we're seeing is those broken up comets. They are probably, based on what we're observing right now, have about 25 million years left before they crash into the surface of Saturn, or, you know, the gaseous clouds of Saturn, the atmosphere. So in 25 million years, if you're planning to be around, you know, take a look at Saturn without rings. And finally, I'm not going to get into this one, but we just had a new visitor pop up. That is Mars directly in front of me. I'm going to switch this around. See if we can't see it here. There, I saw a tiny glint. But Mars is somewhere in there. Yeah, right there, that dot. So you can see all of them are in this kind of line. And that is what we call the ecliptic. All of the planets are relatively on this same flat disk across the sky. And that same flat disk just happens to coincide with where the moon orbits, and also just happens to coincide with where, the zodiac constellations are. And the zodiac constellations are special because of the planets, not the other way around. Mars, about 2 weeks ago, was, use my finger, Mars was about right here 2 weeks ago, and in that 2 weeks, it has slid all the way to where it is now. So Mars is moving at a very rapid pace because, of course, it is inside the orbit of Jupiter and Saturn. So it's moving quicker than them. It's moving faster than them in its orbit. So Earth is playing catch up to Mars. And I think it'll be September when Mars is about where they are at about 9 o'clock at night. So this was a pretty long video for what it is. It's like 3:45 now. But, for now, I'm going to leave it there. There is so much more to see in the sky. It's just I have this light right here. I want it to be across the way, about a half-mile away, where it's a lot darker. But I just came here instead. But, we have Mars, we have Saturn, we have Jupiter, we have the moon, we have all these planets. Make sure you're saying goodbye to Venus. But of course, when July rolls around, make sure you're coming to the Sidewalk Science Center at the Bradenton Riverwalk so that you can use that thing right there. Take a look through the telescope and see Jupiter's moons, see the great red spot, see Saturn's rings. And when Mars comes around, you can see just that iron tint of Mars, the reddish tint, the orangish tint of Mars. And we can talk about Mars and the star Antares that we saw earlier, and how they are related to each other in Greek myth, or Greek origin, I guess we could say. For now, though, I'm gonna head back home, get to bed, and it was good being out here so late, so early, I guess. But welcome back, Jupiter and Saturn. Welcome, Mars, as we say our farewells to Venus. I hope everyone's having a great start to their week. Hope you've been learning a lot throughout these past videos. I'll try to keep them coming. And of course, to all our endeavors, because we have a future to create, I'm Alex Martin. I'll see you next time.